WasmX is the most flexible core library that enables multi-VM support for blockchains, currently Cosmos SDK blockchains. One of our latest additions is support for Golang. Specifically, WasmX enables the execution of WasM modules created with TinyGo. With our Go-WasmX plugin, you can write smart contracts in Golang. You can use these smart contracts with both MetaMask and Kepler. In fact, you can use them with any wallet that supports Ethereum-like chains or Cosmos-like chains. And you can bridge between our various plugins, eWasmX, CosmWasmX, PythonWasmX, GoWasmX, on the same chain or on different chains. So you can communicate between any smart contracts, even those handled by different plugins. And today you will see a short demo of a simple storage smart contract written in Golang. This is the contract. It has a function to store a string variable in the contract storage and a function to load it and return it. The two entry points of the contract are instantiate and main. Instantiate is the contract constructor. For this example, this is empty, and main is the execution entry point. The input data or call data is a JSON string that you get by calling WasmX getCallData, and you will see this soon. The input data tells you what internal function we want to call. In future versions, this main function may be automatically generated. And under the hood, we have this WasmX Go package that is an easy-to-use SDK for our WasmX APIs. For now, we use the WasmX getCallData and WasmX setReturnData and storage store and storage load functions. So now we can compile this contract with TinyGo, and we will use the WASI standard, and we have this simple storage WebAssembly module. To use this, we have our dApp. And we can use our dApp here to upload and interact with our contract. And I am running a local Mythos chain here with WasmX, and we will be using Kepler to interact with the dApp and the chain. So we can go here and just choose our simple storage WASM and upload it to the chain through a Cosmos message store code message from the WasmX module. And in the transaction receipt, we can find our code ID, which is 21. And now we will instantiate, and the code ID has been already filled in here with a label TinyGo simple storage. We instantiate the contract, and in the transaction receipt we will get our contract address. So now we can go to the dApp tab. Our contract address has already been filled in, and we can write any JSON input to send to the contract. So we will call the store function with the input arguments. There is just one input argument, and we will use hello as the string variable that needs to be stored in the contract. And now we can just execute this, and we are using a WasmX message execute contract, and we have our transaction here. We can take this transaction hash and go to a chain explorer and look this up, and we have our transaction here. This is the data that we have sent. This is base64 encoded, so if we copy this and decode it, we have the message that we have just written, the store hello JSON. So at this point, we have just stored a string variable through a Golang smart contract. So let's load and see if our variable has been correctly stored. This is a query, and we get the answer, hello. Let's try another one. Send the transaction. And then load the variable. And we get our newly stored string variable. WasmX is extensible to other compiled and interpreted languages on Wasm. And today WasmX can execute EVM, so any contracts written in Solidity, Vyper, Yule, etc., eWasm, which is gas-efficient EVM as a Wasm module, CosmWasm contracts that are usually written in Rust, Wasm modules compiled from AssemblyScript code, Python smart contracts interpreted with a WasmX meta contract, and now Go smart contracts.